last but least, not the least talk of VMCAI is going to be by Julian Erhard, who is going to be telling us about how he likes to bridge the semantic divide with ghosts. Can you speak again?
Yes, hello? Yeah, okay. Good. So then we can come to the definition of witness validity with respect to semantics. So we say that a witness for a given program is valid with respect to semantics if and only if the witness instrumented program is safe with respect to the semantics. So that means the witness is valid if the original program is safe, so all the assertions in the original program do hold, and also every additional assertion that is introduced by the witness also holds. Now we stated some theorem that the local trace semantics and the interleaving semantics are actually equivalent with respect to safety. So that means that every program that is safe with respect to the interleaving semantics is also safe with respect to the local trace semantics. And so that required some proof engineering, which I will not go into very high detail. But what we basically had to do was to define a class of traces, which were not quite local traces, for which we could construct interleavings and vice versa. And then we showed that for every local trace, we can extend it to one element of this class of traces, so that basically whenever we have a local trace that violates an assertion, we can obtain an interleaving that violates an assertion, and vice versa. So based on this notion that the safety coincides for these two different semantics, and based on the definition of witness validity, which is based also on safety, we can now make the claim that a witness is valid with respect to the interleaving semantics exactly if it is valid with respect to the local trace semantics. And so this is the core theoretical outcome. That basically means that this ghost witness format makes sense or yields the same result whether you view it from the local trace point of view or whether you view it from an interleaving point of view. So, and besides these theoretical results, we also have introduced a format which extends an existing format for software verification witnesses, this witness 2.0 format, which is also recently now used in the software verification competition as VComp. And here you can see an example of how one would specify that there's some ghost variable and that this is updated at some specific location. So this is it with respect to the format. So now we come to the evaluation. So we implemented something in two tools, namely in Goblin, which is an abstract interpreter. We implemented a means to generate ghost witnesses. And in Ultimate Gem Cutter, which is a model checker, we implemented a means to validate or check witnesses. And we performed the experiments on the concurrency safety main category of SVComp, which contains several hundred tasks. So what witnesses did we look at? So we equipped Goblin, so two different analyses that are implemented in Goblin with means to generate ghost witnesses from their results. And so one of these analyses we call protection-based, and the other one we call mutex-meet. And both of these analyses are actually justified with respect to proofs based on local traces. So our first research question was, can witnesses that are generated by Goblin So by one tool, can they be confirmed by some other tool? And indeed, we found that most of the witnesses could be confirmed. So for the one analysis, for this protection analysis, we generated 181 witnesses for correct programs. And most of them could be confirmed by ultimate. So that is all of the claims that were made by the witness do hold according to ultimate. And then also for the other analysis, we generated 217 witnesses, and most of them, again, could be confirmed by ultimate. And we did not only look at the correct programs, so to have a broader set, we also looked at the incorrect programs. But again, ultimate here only had to verify that all the claims made by the witness created by Goblin do actually hold. And here, again, most of the witnesses could be confirmed. Now, the question with respect to performance. So sometimes witness validation can actually speed up the run of the validator compared to the validator just verifying the property on its own. But sometimes it does not speed up, and sometimes it becomes slower. So what is the case here? So in our experiments, when ultimate had to validate the witness, all these witnesses for the protection analysis, there was, so this is the overall runtime in hours, so there was some slowdown compared to just verifying the property on its own. And so this also holds similarly for the mutex meet analysis. So there is some slowdown, but it's not too bad. And there was even one case, so for one witness, ultimate was faster in validating the witness than verifying the property on its own. So now another key question is, can this witness format actually help us with increasing the quality of static analysis tools? So because one of the reasons why we actually want to have witnesses is to increase the trust in the verdicts that these tools make about programs. So and actually during the development of this format, we found quite some bugs in both ultimate and Goblin, in total 29. And so there were some examples where Goblin previously computed unsound information, actually. So because of some errors in the domain, or because some analysis did not treat some variables correctly. So there were even unsoundnesses that we observed because of these, because of the witness, and that we found out because of the witness. And then on the other hand, for ultimate, which was the tool that validated the witnesses, we also found that some code that was already doing, so that for the validation contained some mistakes that were actually already present for the witness validation without ghosts, but this bug was not recognized previously. So, but these are just some examples of the bugs that we found. So to summarize, we have bridged the semantic guide divide between the interleavings and local trace semantics by using programs as the ground truth, building on this on the ghost instrumentation, and provided a machine-readable format that can be exchanged between tools, and it facilitates the exchange of information, and already was shown to help find bugs in static analysis tools. So that's it, and so I'm happy to take your questions.
Yes, thank you for the talk. I have a whole list of questions, but I'll start with one, and we'll see. Yes, so I was a bit confused by your translation of this kind of English language statement you wanted to verify about like when the mutex is not locked, something is used or something, into the formalism where you, if I understood correctly, asserted this invariant at a single line, whereas if it's an invariant, it should hold everywhere, right?
Well,
so
I mean,
that's a bit confusing.
Okay, so yes, so I mean there are different notions of invariant. So one thing is you can still specify an invariant that holds at some specific location. So then it's like a location invariant, what we would say. And you are right that one would also like to be able to specify that something holds globally, right, at every program location. That is also something that one would like to have, but we currently did not have this in the proposed format.
But the English language version you had was whenever. But
yes,
like what you actually formalize is at the beginning, like after the first line of the program.
Yeah, so I mean, the thing is that you can still express with this is that it does, I mean, the other thread is, you don't know, so if you don't have the ghost, you cannot really specify where is the other thread, what is the other thread doing. And now with these ghost variables, you can specify whether the other thread is in a critical section or not, or whether any thread is in a critical section or not. And so that is what these ghost variables
are. Yeah, the ghost variables are clear.
Yeah.
It's the placement of the invariant. Like, yeah. I mean, I would have expected at least something like just saying this at every single line or something like that.
Yes, I mean, one could introduce that, but that is currently also a limitation of the existing format that you have to specify it by line. So one could introduce it, but currently we do not have that.
Okay, thanks.
Yeah, maybe other questions. Kedar, and then we can do the ping pong.
Yeah, thanks. That was really interesting. So I was sort of maybe going to build on this, the previous question, is that, so based on your explanation, like with interleavings and local traces, I was starting to think of this as a modular verification method. So you also introduced Ovicki and Grease's work, which is, the reason they have ghost variables is because they want to construct compositional or modular invariants. So you have, and just what you were explaining, that the ghost variables kind of tell one process what the other process is doing, right? So first of all, is that true? Is that how you're thinking about these ghost variables and the invariants that you write with them?
Yes, so I mean these ghost variables are, I guess, in general quite powerful. But yes, I mean the main idea is that with the state of the ghost variable, you can basically encode some information about the progress of multiple threads, and yeah, thus you can really in your C expressions or in your assertions you can then use this information.
Yeah. So then the other question was with your experimental results. So is the verifier actually checking these invariants modularly, like one process at a time? In which case it should be really fast, or is it building the entire state space? I mean, I was surprised that the verifier was taking so long, and that in some cases it was almost the same time as the actual analysis, right?
I mean, so actually it was even slower than so it had, because I mean the reason for that is because it basically had to construct this ghost instrumented program, right? And so there was more code to analyze and also more assertions to prove. So this means that there were more proof obligations. And well, yes, so with respect to how does the verifier work? So this is this ultimate gem cutter. So it's a model checker that does some commutativity reasoning behind the scenes. So it tries to reduce the overhead of the analysis of concurrent code, but I mean there's still some scalability problems. So that yeah. So yeah.
I would say this suggests that you maybe need a different verifier. So just this sort of suggests that you need a different verification strategy instead of just giving it to any model checker. because now you have these ghost variables. You should be able to just check the code or the invariance of each process independently of the others. I mean, that's what my intuition says. Yeah. So you should just be able to analyze one process at a time, verify it very quickly.
Yeah. I mean, that ideally that would be the case. The thing is, with these witnesses, it's always a question on how much information is actually expressed in the witness, and does the information that is expressed in the witness, does it suffice to show the property that holds? And because sometimes the properties are quite intricate, and this is sometimes hard, and there are even some technical limitations that the witness, currently also our witnesses, are not able to express everything, because, for example, arguing about things that could be pointed to and so on is a bit hard in this format still.
I think I tend to agree that it's a bit odd to have a witness which is hard to check. Like, the point of a witness seems to be that it's easy to check. But anyway, actually going on this pointed to that you just mentioned, so a common approach to verifying concurrent programs is separation logic. So do you have any thoughts on how one would take a separation logic proof and turn that into your witness format? Or what would have to be added to make that possible? So
for separation logic, I could not, at the top of my head, answer this, no.
Okay, fair, thanks.
All right. Oh, it's 5:30. Yes, please take it offline. So your talk is introducing a lot of questions, so please stay offline, take it. Thank you everyone for attending VMCAI 2025, and we had a great set of talks. Let's thank all the speakers and all that.